Alright guys, so we are going to do the cam program for this part right here. This is the Advanced 202 lathe. Now one thing you want to notice is the largest diameter is 0.924, so depending on what country you're in, we're here in America, so we're going to use imperial units. The stock size that we have most available to us is going to be 1 inch. Okay, so we'll make this out 1 inch round. If you're European and you use the metric system, let's see, 0.924. What is that? It's 0.924 times 25.4. That's 23 millimeters. So you'd probably use either 24, probably 25 millimeter round bar. Okay, so the overall length is 0.927 inches. So we're gonna say that we have to make a production run, okay? Which means we'll have a 1 inch round bar in the lathe, but it's gonna be going through the spindle bore. All right. So we'll have a piece probably, we'll say about 20 inches long, and I mean usually the stock material comes in 12 feet, so you know however many pieces you can get out of that. So that's the first thing. Also we have a groove, so you'll have to make a groove tool, and the groove width is 0.162. So your groove tool will have to be smaller than 0.162. Also notice these corners are just straight corners. There's no chamfers or radiuses. We're going to add a chamfer to each one of these, okay? Even if the print doesn't call for a chamfer, I would still add like a 10,000th chamfer. So I went ahead and added the chamfers here, and if you don't know how to do that, pretty much what you do is, here, I'll just delete it. Okay, so what I would do is go to modify, chamfer, and click on each one of these edges right here. And we'll make that 10,000ths. Okay, now that's going to prevent us from having any kind of burrs or sharp edges. Okay, you don't want to be a bloody machinist. So we got our chamfers here. Go ahead and hit save, because I like to, it's a good habit to hit save. So we'll go into manufacturer mode, and we have to tell the software what we're doing here in our setup. Okay, you know, so we're going to tell it we're running it on the lathe. So operation type is going to be turning, and you can see that it already selected a Z-axis. Now that's the wrong side, so we're going to run the other side. So I'm going to go to flip Z, and if for some reason this didn't come pre-selected on your part, what we're going to do is we're going to go to Z-axis, and we're going to click on this edge right here. And what that'll do is it'll put it in the center of your part. Okay. So the next thing you'll notice is you put the origin on the stock. I don't like doing that because when you're watching your distance to go during setups, and if you ever have to edit any code, it makes things a lot harder because you have to add in this distance to, you know, whatever you're doing. It's a lot simpler. It makes the G code a lot cleaner. And if you change the origin from stock front to model front, okay, and notice our origins right here. Okay, so I'm going to go to the stock tab right here, and we'll go fixed size cylinder, and we'll put it at 1 inch diameter. The length, let's put it at put it at 20. Okay. Now notice the model's in the middle of our stock. We don't want that. We want it to be at the edge. So what I'm going to do is model position. We're going to put offset from front. And we want some material. If the stock is right on the face, your Z0, you may have trouble facing it, okay? Basically because the software thinks that there's nothing to face off because it's, you know, because your Z0 is at the stock. So what you want to do is we'll offset this about 50 thousandths. Alright, looks good. And just as a note, a side note, if you have like a bad saw cut, say it's kind of slanted at an angle, you know, you don't want to add some more. 50 thousandths is good. Typically, the larger the diameter, the more I add. That's because when you're sawing larger diameter stock, the saw tends to walk even more. So you know when you face it, it may not clean up. And you know, vice versa. The smaller the stock diameter, the less you have to face because the saw is going to walk less. But 50 thousandths is good. Anywhere from 20 to 100 thousandths is fine, depending on how straight your saw cut is. Okay, so we'll go ahead. Looks good right there. The chuck, yeah, we'll leave it at that. Alright, so I'm going to rename this Op 1, even though we're going to do this in one operation. And we'll go ahead and hit save. Alright, and let me check something. Alright, making sure I'm still recording. Okay, so first thing I'm going to do is face it. Some people like to turn to OD first and then face it, depending on what type of material you're running. Sometimes turning to OD first is better because the shavings coming off the OD may scratch the face. So it's all preference, you know, if you want to turn to OD first or face it first. A lot of people like to face it first because then they have a Z0 datum to work off of, so they go to measure other dimensions and you know, distance from this groove to here, you know, to make sure it's right on the first initial piece. You know, if it's faced off right here, it's a lot easier to do that. So we're going to face it, so I'm going to go to turning face, and we're going to select our tool. Alright, so I'm going to select this face and OD tool, and if you don't have a tool for that, what you would do is you would create a tool by hitting this plus sign. Now notice this is grayed out. That's because it's got to have a place to save it. So you would click a document. I like to make a tool library just for like lathe tools or mill tools. If I'm using a tool that's, you know, specifically for that job, I'll save it to that document so I don't have like this long list of tools I have to search through. A general tool like, you know, face and OD, you know, you could save that to your library or whatever. But anyways, I don't need to create a tool. I already have one. So I'm gonna go to face and OD. And now notice when I selected that tool, Fusion already created a toolpath. Okay, this toolpath would work. I can literally hit OK, and that would be fine. You know, depending. Let's rename it. I like naming these toolpaths. You know, this would be a suitable toolpath depending on your print specs and the type of material you're cutting. You know, aluminum. You know, taking 50 thousandths off, fine. If you're cutting stainless steel, you know, you're gonna want to have a finish pass. We'll go ahead and look through these settings. So these are the preset settings, and this will work. You can put in multiple passes where it takes 2 passes, and this should work out fine right here. Now, you see how it cuts at an angle? I really don't like that, because when you're trying to edit code with the machine, it adds in a lot more code, because you got rapid right here, and feed in at an angle, then feed down, then feed out at an angle. Okay, so sometimes I like to change this. Is it 90? All right, so notice as that changes, we'll put it at 0 degrees. The green line starts here and goes to the left, right? If I put it at 90, hold on, let's look at this. I want to check this out. Fusion 360 is great software, but they're always changing stuff, and sometimes when they change things, it'll work a little bit different. Okay, look, that looked good. It went kind of fast. I'm gonna rewind the simulation, and you can do that just by clicking anywhere in this empty space on your screen, and you left click and hold the left mouse button down and pull it, and it'll rewind it. Okay, so we're gonna go slower, and what we're looking for is make sure it's coming down at the right spot and then coming off of the part correctly. Like right here, the tool is actually dragging up. Let's see. Okay, so right here, this is a problem right here, because when it goes back up, it's touching the face. So if you're wrapping it up, it's gonna wrap it up quick, and it's gonna leave little scribe lines on your part. Okay, depending on what type of material you have, you may have a smooth surface finish, and when it goes back up, it could it could leave scribe lines or drag shavings across and kind of mess it up some. So let's see if we could change that. Okay, so I have it at 90. Man, I really don't like that. So we got full retraction. All right, let's uncheck this save, same as lead in. And let's put this at 0. Okay, so when I put it at 0, it now does this. Yeah, we'll check this out. So I'm gonna right click on it. I'm gonna go to simulate. See how it comes off the part now? That's the way you want it. All right, so that's our face. Go ahead and hit save. Okay, we'll turn VOD. So I'm gonna use the same tool. And also, side note, watch your maximum RPM. For some lathes, this may be too fast right here. Okay, so we're gonna turn VOD. Let's see, the geometry tab, let's leave that how it is. Let's just hit radii and see what kind of toolpath it gives us. Alright, so notice this little dip right here. Now, why is it doing that? Okay, so the tool can't get in here and cut that groove. There's not enough clearance. So what you're seeing is the tool, basically the toolpath or the software is making it cut as low as it can without gouging the part. Okay. Now typically you don't want to cut it like that. You want to cut it straight across, and then when you use your groove tool, you cut out the groove. So let's change that. So I'm gonna go to edit. And on my passes tab right here, it says grooving. I have it on allow radio grooving. I'm going to put it on don't allow radio grooving. So when I hit OK, it now cuts straight across. It ignores that groove. If I simulate it, okay, looks good. Notice this blue line right here. A lot of people, a lot of new users, they get confused when they see this. Basically, what you're seeing, if I rewind it some, well, let's just rerun that. Okay. Well, alright. So right here, what you're seeing is your tool nose radius on your insert. Basically, to compensate. Basically, what you're seeing is compensating. Okay, so you have like a theoretical 0. So this is your Z0 and this is your X0. So where these intersect, basically it does the math off of that. So it is compensating. So if you see this blue line run into the part right here, don't worry. It's gonna look how it does in the simulation. You're fine. It's just compensating for that tool nose radius. Okay, so notice these angles right here. If you want to change that, you know, a lot of people really don't like that. Let's see. Oh, well, they have changed some of this stuff. Usually, let's put this at 0. Is it 0 or 90? Okay, so it fixed my lead in right here. Hold on. I haven't written any Lathe programs in a while, so I'm a little rusty. They kind of changed some stuff around. So I put that at 0 degrees. That's my entry angle. Now my okay, so usually I have a lead in and a lead out. It's not usually called angled entry. It's called lead in and lead out. I have an entry angle. I don't have an exit angle. Okay, I guess that's something new. They're not gonna let me change that. They'll probably do away with that on the next update. Also, I would use can cycle. Makes things simpler. And let's see, we'll save 10 thousandths for a finish pass and 2 thousandths on the Z. So it's gonna say 10 thousandths on the X on the diameter, and it's gonna save 2 thousandths on this face, these back faces right here. All right. So we still have to do a finish pass. Now, if you zoom in, notice the stock is above the actual part. That's because, you know, this is 10 thousandths here, and we got 2 thousandths right there. So we still have to do a finish pass. So I'm gonna name this OD rough. Okay, so we still got to do a finish pass. So this is our roughing. And you could just cut this, depending on what material you're cutting and what kind of surface finish is required. You could just not save material for a finish and just cut it all in whack. In this example, I'm just going to I'm gonna do a rough and a finish. So I'm gonna go to finish, starting finish. We're gonna use the same tool. This time, because it's a finish pass, I'm gonna go slower on the feed. We'll go 6 thousandths per revolution. We'll keep the default geometry settings, default radii settings. Passes, I wouldn't worry about step over because it's just taking one pass, and we already roughed it. And let's see. I think we had that at 0. Okay, so look what it gave us. So it's trying to cut the groove again. So what we're going to do is we're going to go back to the passes tab and don't allow grooving. So now it does this, and it's got a weird move right here. That's totally acceptable, but let's see if we can change that. See, on the finish pass, it has lead in and lead out. On the roughing, I guess they changed that. They'll probably do away with that, because they'll probably find a lot of machinists, you know, don't like the lead in approach. They don't like the angle approach. They want, you know, lead in, lead out. You always want to give a programmer more control over your toolpath. Okay, so we might be kind of screwed on this. Let's see. We'll put this at 90 degrees. Okay, now notice this yellow line is lower than this where the chamfer is. That's because it's compensating for the tool nose radius. Alright, so actually it has to go lower. If I remember correctly, it goes 28 thousandths lower. So I had changed my lead in length to 0 and my angle 90 degrees, so it's going to look like this. Alright, so notice, let's rewind that. Oops, pause. Alright, so I'm going to rewind this some, and what you'll see, it's compensating for that tool nose radius. So it hits right here, that's your theoretical Z0. And notice it's actually touching right there, okay? So that's why your toolpath line is lower than the actual geometry. Okay. Looks good. Let's name this OD Finish. Okay, so now we'll do the grooving. So I'm going to go right here, turning groove. And I'm going to select a groove tool. If you don't have a groove tool, I already made one. Well, hold up. One thing. So we have to part this off, right? And we're not grooving very deep. So all I like to do, if I can, to minimize the amount of tools you have to use, I'll actually use the part off tool for grooving, and then I'll come in and cut it off. Okay, so that's a little trick to make things simpler. So our groove is 0.162. All right, I don't know why. I'll regenerate these up. I don't know why I have warnings. Okay, so we'll go grooving. And you may have to add a groove tool. Remember, you just hit this plus sign, and if it's grayed out, select a place to create the tool. Now, I already created a tool. We'll use this 98 thousandths. Okay, so grooving, I usually go slower. You know what, that's fine. Usually your feeds and your spindle speeds, your surface speed is going to be slower on grooving. We'll go about 450 and 5 thousandths feed. Okay, so right here, your geometry. Now, Fusion made it updated where you don't have to do. Let's just hit OK. See what it does. All right. So if I just hit OK, notice it's trying to peck and groove all the way along this OD. So that's what we need to fix. So what we're gonna do is we're gonna go to the geometry tab, and it needs a starting place on the Z distance, you know, and a place to end to stop grooving. So what we're gonna do is I'm gonna go to selection, and I'm gonna get these chamfers too. So I'm gonna select right here, and on the back where it's gonna stop, I'm gonna go to selection. And I'm gonna select where this chamfer ends here. All right, now I hit OK. I have a toolpath that looks like this. Let's simulate that. Okay, see it? It's not actually. What is it doing? Alright. So it does this weird step-in motion, right? Let's fix that. So I'm going to edit. And let's go to the radii tab. Now we already turned to OD. So your inner radius, let's go ahead and change it. Some of the stuff, Fusion 360, the software you may not have to change. But we're gonna go off of basic CAD/CAM rules, even though the software is getting more intelligent, and the toolpaths are getting better. Sometimes you don't have to actually go through and change these settings, but let's go ahead and do it. So on the inner radius, I'm gonna go to selection. I'm gonna click this OD, and now you'll notice this blue lines right there. Outer radius, so that's where it's actually going to start cutting. I'm going to put it on selection, and I'm going to select this OD. Now, yeah, we'll try that. Let's hit OK. Okay, it's a simpler toolpath. Simulate it. Okay, so notice it alarmed out right there. That's because there's something in the settings or the software but basically it doesn't want to. That's too much. It comes down and it would feed across, right? Which for this groove tool, you know, you could break a groove tool or push an insert out of a part off blade if you're using the part off. So it's too much material. So we'll go ahead and close this out. I'm going to edit. And on my passes tab, let's see, we'll change this. Okay, right here is the grooving pattern. We'll do partial step down. Let's see what happens. Okay, it's gonna do the same thing right there. Let's change this to 30 thousandths. Okay, that's not what I wanted. Okay, so okay, so we got a number of stepovers. Hold on, let's bump that up to 2 and see if that actually gives us what we want. That doesn't quite look right. Oh, here we go. Let's see, outside grooving, direction, front to back. Okay, this maximum groove step down. Put it at 20. It's not actually. I gotta be honest. Okay, so let's look at this. So if I measure this diameter, we have 0.622. Okay. Now, if I measure this diameter, we have 0.44. Okay, so we go minus 0.444. Now, that's 0.178. That's the diameter value. So we need to divide that by 2 to get the true depth of that groove. So it's 89 thousandths, right? So if our step down is at 20, it's not actually turning on that step down. I don't know why. And I had a problem with this before. Now usually grooving is pretty simple. Like you just click the starting point, ending point, and how deep you're going, and bam, it gives you a toolpath. You know, I mean, it usually, no matter what, it gives you a toolpath as long as that insert can actually fit in the groove. You know, so it's going off of the width of the groove insert and how much stock material you're saving for a finish on your stock to leave. So for some reason, I don't know if we like hit a bug on this newest update. They added some stuff onto the groove cycle here. Plus, I haven't used it in a while, but I mean, I've done many groove operations on different software, and I can tell you it's not supposed to do that. See the horizontal blue lines? That's going to be this distance right here, and from here to here is 89 thousandths. So it's not actually taking it in steps, and I don't know why. And I had this problem earlier. This is actually the second time I recorded this video, and I don't know why, but I had a lot of trouble with that groove, and I spent like 30 minutes on it, and usually it takes me about 30 seconds. Okay, they changed some stuff, and it could be user error. I don't know, but I think there's something funky going on with their groove toolpath. Okay, I almost guarantee that there's some kind of bug in it with this Fusion 360 update. By the time you watch this video, they may have changed it or fixed it. Okay, that's the beauty of cloud-based CAD/CAM software, is they update it all the time and make it better and better. It's just sometimes they update it, sometimes some bugs slip through the cracks. Okay, but anyways, I had this trouble earlier, so this isn't the first time I recorded this video. And let me show you what I did. So this is what I did earlier. So on my groove, for my settings, I had my maximum step over at 40 and my pecking depth at 0.4. Huh. Okay, so let's go back here. So one thing you could do is we'll put it on full step down, but we'll make this like 20 thousandths. Put it on pecking. And let's see, pecking depth, what is that? That should be good. Let's see what happens. Okay, so it's giving me issues there. Let's go back this one. So we'll do, you know, by the time you watch this video, they may change this, okay? I can tell they're definitely doing some new stuff and settings and parameters on the grooving. I don't know why. It was working fine. I guess they're trying to give the user more control of their toolpath, because sometimes you have to do some special stuff. So on my settings here, I have my direction up and down only, and right here. So these are my settings right here. So you just want to copy that. My maximum grooving stepovers 0.04, my pecking depth 0.4, and this is what it looks like if I simulate it. That's what it should look like. So I would just copy this. That seemed to work pretty good. Make sure if you're using a larger groove tool, make sure that it'll fit in here. And sometimes these settings, it gets trickier. The larger the groove tool, depending on what these settings are, it may conflict with the actual toolpath. And you know, the software has collision detection, and basically it's going to try to avoid, you know, if you tell it to back up 40 thousandths and it's going to hit the, you know, on the other side of this boundary right here, you know, it's not going to give you a toolpath, or it's going to give you some kind of error message. So just make sure you got that. But this should be good right here. I like to name my my toolpaths. I'm picky about the names. Okay, so now we'll do a part off. So I'm gonna go over here. I'm gonna use the same tool because I'm actually grooving with the part off tool. And what we'll do, our geometry. Now by default, this should be fine. Now, the only thing, we have a chamfer right here. Let's see if we can get to put a chamfer for us. So I'm gonna go to edit, geometry. Let's do this. Put it on selection and put it where this chamfer starts, and let's see if that changes our toolpath. That. It's not showing that they're stocked right there. Like if I hit undo, see how there's, you can see the stock right here, it doesn't have the chamfer. And if I hit redo, it doesn't show that anymore. But my toolpath looks straight. I don't see a spot where it's, there should be a spot in the toolpath where it cuts at an angle to actually put that groove there. So let's simulate it. Alright, see, that's a problem right there. Now, a lot of times, writing programs, you just have to know what to look for. And that's just from experience. You just have to write programs, and you go run it, and you run into little problems like this. Your part would be short. You may not even cut that. You've been like, man, why is my part coming out short? You know, you may reset the tool and sit there and look at the code and jack with parameters. And the whole time it was because we selected this line right here. Let's see if we can fix that. You know what, let's try this edge break. Let's take that back out, put it on stock back. Hold on. Was it stock back? I don't remember. Uh-oh, you got a crash there. That gets you fired. Okay. Oh, let's just hit undo. Hit undo again. Okay. So we're back to where we started. We don't have the chamfer. It parted off. And also, as a side note, you don't have to chamfer it with the part off. You could actually use the turning tool. But with that said, you would have to use, because this is a 45-degree chamfer, you wouldn't be able to use the 80-degree insert we're using. Like this is an 80-degree insert, right? There's not enough clearance for that tip, that cutting tip, to get down there and cut that chamfer. You would have to use a tool that's less than 45 degrees, where the chamfer is, okay? So you would have to use a 35-degree tool. But that's for a whole other video. Okay, so back to the part off. Let's see if we can fix this. So on the geometry tab, let's try this edge break. I haven't actually used this. Let's chamfer width 10 thousandths. It doesn't look like it fixed it. Come on, Fusion 360. Okay, that's what happened when you selected that. Not what we're looking for. Now that could be because of these radii settings, okay? So let's check it, because it's starting to appear, you know, these default radii settings might need to be changed. So outer radius, let's change this to this OD. And inner radius, we'll just say it's going to go to Z0, so stock ID should be fine. Let's see what happens. Still doesn't look right. Not right at all. It's not even feeding down far enough. Stock ID should be fine. Maybe it's model ID. So make sure you simulate this. Fusion 360 is really good at some stuff. Some stuff, you know, they need to sit down with some machinists and kind of make better. So the model ID is still not going to the center, okay? Let's put diameter and tell it to go to 0. That don't look right. It's not too bad. Simulate it again. To be honest, I didn't think that was going to work, but so it comes down. And pecks in to give itself clearance. And then it comes in at an angle. That'll work. Now, one thing I didn't like is when it did that, it's going down, and it's got to do that. It's got to get clearance. But it feeds all the way back up, then comes over here and cuts at an angle. That will totally work. But I like to, I don't know, I don't like to cut air. I like to minimize the distance it has to retract and feed. So what I'm gonna do is the outer radius. Let's click this retract. We'll put it on the outer radius plus 0.1, and clearance, we'll also make that outer radius plus 100 thousandths. Alright, so come on, what is the box doing? Alright, I'm gonna hit save because software's acting a little weird. Alright, so I'm gonna simulate this, and with the new updates, changes, it goes down And see, it didn't feed. It didn't come all the way back up. It comes down, then comes over here and cuts that. It does it in 2 stages, 2 steps. The reason why is because if it just feeds in at an angle, you're gonna have a load on that tool, and it's going to deflect. So it comes in, cuts down, then moves over and cuts that angle. So it takes the load off of the tool. So it comes in, steps over, and feeds. Alright, there's your program. Let's go ahead and name this cutoff. Make sure you hit save, and I'll see you guys next time.